All right, coming right back at you again with Chapter 9 answers. This one I decided I'd try to type them up a little bit so you can read along with them so it's not so hard maybe to follow. I understand that sometimes my writing is not as neat as it should be. But this will be Chapter 9. Chapter 9 we're doing two proportions, doing two means. So in other words, we're doing two sample testing. In the previous, we just did one sample testing and comparing it to what we claimed things were. And now we'll be comparing two different samples. So in this one, we have two proportions. The first question is notation. Suppose you're given the following study. Group A had 68 in its sample, of which 37 of them succeeded in their task. Group B had 75 subjects, with 13 of them succeeding in their task. Identify the values of N1, P1 hat, Q1 hat, N2, P2 hat, Q2 hat, P bar, and Q bar. Okay, round all the values so they have two significant digits. Okay, so the first thing we need to do is we see that N1 is going to be 68. P1 hat is going to be 37 over 68 because, remember, P1 hat is X over X1 over N1. And then Q1 is just 1 minus that. And that's how if you added those together, you get 1. Again, same thing through all those. P bar is calculated as X1 plus X2 divided by N1 plus N2. So sometimes I get students who are really struggling to get what X1 or N1 is or P hat is or things like that. Just remember that basically if somebody gives you P hat and you don't know X, you can easily solve for it. X is just going to be equal to N times P hat. So you can solve it that way. All right. Moving on to number 2. I'm going to try to make this video much shorter than the other two videos. Black and white. So first thing it says, problems 2 through 4, test the given claim, identify the null and alternative hypothesis, test statistics, p-value, critical values, make a conclusion about the null hypothesis, and a final conclusion addressing the original claim. Okay, so a study was conducted to determine the proportion of people who dream in black and white instead of color. Among 306 people over the age 55, 68 dream in black and white, and among 298 people under the age of 25, 13 dream in black and white. Based on the data, do we dream in color? We want to use a 0.01 significance level to test the claim that the proportion of people over 55 who dream in black and white is greater than the proportion for those under 25. Now you might be thinking, why would you test this? Well, it's just seeing how you were raised. The age demographics of maybe 55 had more black and white TVs when they were younger. So they might dream more likely in black and white. So that's one of the things that might be thinking here. So the first things you were asked is test the claim using a hypothesis test the claim by constructing an appropriate confidence interval, and finally C, explanation given for the results is that those over the age of, an explanation given, so explaining it. Can the results from part A and B be used to verify that explanation? Okay, so bear with me, I wrote this out to try to make it a little easier for you. So in this case, we have P1 is equal to P2 is the null. Alternative is that P1 is greater than P2. In other words, the people that dream, this age demographics of 55, dream in color. The proportion of them dream in color more likely than, more than the under the age of 25. Dream in black and white. Sorry, dream in black and white. Test statistic, we gather that. We get 6.44. Critical value of 2.33, p-value of 0.001, reject the null. Right, so there's sufficient evidence to support the claim that the proportion of people over 55 who dream in black and white is greater than the proportion for those under 25. Okay, so maybe wondering, how do we test the claim? All right, I'm going to show you some tricks on your calculator for this. This might be worth it to watch. We'll go to stats, and we're going to do tests, and we're going to do a two-proportion z-test. So we need to identify what X1 is. Right now you might be thinking, what's X1? Well, we're thinking about among 306 people, right? So 306 is the N1, and 68 of them dream in color, or dream in black and white. And 298 is the age under age of 25, and 13 of them dream in black and white. All right, and what are we dreaming? What are we claiming? Test the claim that the proportion of people over 55 who dream in black and white is greater than the proportion for those under the age of 25. So in other words, P1 is greater than P2, which is what I have selected here. Right? So that's up here. So that's saying P1 greater than P2. Calculate. and we get the test statistic right here. It's a normal distribution, so that's why it's this one. And then if you go down here, here's your p-value. Some of you might think, oh, p-value is 6.01. Oh, so I clearly, I fail or reject. And the answer is no. Remember, you got to read all the way to the end. You have e to the negative 11th, which means this is actually 0.000000006, right? In other words, 10 zeros between the decimal and 6, okay? In other words, this is very small. And so in this case, you would reject the null that they are equal in favor of the alternative, okay? It also gives you all your summary stats too. P1 hat, P2 hat, P hat, N1, N2. So have all those pieces of information, which is right here, what we see, okay? Now it says, do a confidence interval. So because the confidence interval limit do not include 0, right? So this is our confidence interval we find. We have 0.117 to 0.240. And you're saying, well, I don't know how to do that, right? So I'll show you on your calculator again. You can do it by hand. It's just going to take a little longer to show the calculations. But you go to tests, and in this case, you're doing a 2 proportion z interval test. All right, and you just plug in those numbers. Oh, luckily, they're all in here for this case, except for we're doing a what confidence level? It says 98. Let's do 98 and see if we get the same. Yeah, and we get the same. So again, stat, go all the way to tests. And I know you can pause the video, so it's easier to probably find this, but 2 proportion z interval. And then just plug in your numbers and stuff. Perfect. All right. The results. So let's go back and make this a claim that basically is anything that, if you're riding a bus and you're telling somebody about this research study you've been on and what you found, you want to be able to say something that's not saying reject the null to them, because they won't understand that. You want to say something that makes sense to them. So the results suggest that the proportion of people over 55 who dream in black and white is greater than the proportion for those under 25. But the results cannot be used to verify the cause of the difference, right? So we're just showing that this is happening, but we can't tell you why it's happening. So that would be something that you might further delve into for research. Okay. Moving on to ginkgo. Ginkgo for dementia, all right? So the herb Ginkgo biloba is commonly used as a treatment to prevent dementia. In the study of the effectiveness of this treatment, 1,545 elderly subjects were given ginkgo, and 1,524 elderly subjects were given a placebo. Among those in the ginkgo treatment group, 246 later developed dementia. Among those in the placebo group, 277 later developed dementia. So, for example, this might be for a lot of you guys that are going into the nursing field. This is a common study where you might read and you have to be able to understand what's going on with the treatment group and what's going on with the placebo group, and be able to determine whether it's actually significant or whether it's something that should be used in treating, for example, dementia in this case. Okay, so right off the bat, we need to figure out, are we talking about proportions? Are we talking about means? Well, hopefully you guys have picked up that we have proportions, and that it's you're saying how many were given, so this 246 divided by this will give you your P1 hat, and this divided by this will give you your P2 hat. Okay, so that's where you want to be able to identify all the X1s, X2s, N1, N2, and then be able to do P1 hat and P2 hat. Okay, so it says test the claim using a hypothesis test, test the claim by constructing an appropriate confidence interval. So just like we did in this problem before, you would go through the same steps, okay? And just to verify, hopefully if you did it on a calculator or if you did it by hand, hopefully you get these results. P1 equals P2 is the null. Alternative is that P1 is less than P2. In other words, they develop dementia at a lesser rate because they actually get this drug, ginkgo biloba. Test statistic, we get negative 1.66. The critical value is 2.33. So in this case, we would fail to reject. Right? The p-value is greater than the significance level. So we fail to reject, and there's sufficient evidence to support the claim that the rate of dementia among those who use ginkgo is less than the rate of dementia among those who use a placebo. There's not sufficient evidence to support the claim that ginkgo is effective in preventing dementia. All right. Number 4, are seatbelts effective? A simple random sample of front seat occupants involved. So among 2,823 occupants not wearing seatbelts, 31 were killed. Among 7,765 occupants wearing seatbelts, 16 were killed. All right. Who wants airbags is what this study came from, right? We want to use 0.05 significance level to test the claim that seatbelts are effective in reducing the claim. So the first thing you need to do, like if you're answering this question, and let's say you didn't have all that, right? Test the claim using hypothesis test. Well, first thing you need to do is figure out, are we talking about proportion or mean? In this case, we're talking about a proportion. And when we know that, we need now to figure out, are we talking about 2 sample or 1 sample? In this case, we are talking about 2 sample. Sorry. And that's why our null will be that P1 equals P2, and alternative is that P1 is greater than P2. Well, that's part is going to be the part that we need to do is reducing the claim, right? Test the claim that seatbelts are effective in reducing fatalities. In other words, there's more deaths for the first group than there are in the second group. So you'll be able to figure those kind of things out. Now, we want to do the test statistic just like we normally calculated before. Let's say it spits out a p-value of this. Well, do we reject? Well, we compare the alpha value and the p-value. In this case, we reject the null because the p-value is smaller than the alpha value. So there would be sufficient evidence to support the claim that the fatality rate is higher for those wearing seatbelts. Now, if you want to construct a confidence interval, just like we did on the previous problem, you would do 2 proportion z interval, and you'd construct it. Now, here's where it's important to understand this. Now, in this case, you're wondering, why does 0 matter? Does not include 0. Well, we have this null hypothesis that P1 is equal to P2. The pause there was to make sure that this is on camera. So this part right here, if you were to rewrite this, go down here, you could rewrite this as the null is that P1 minus P2 equals 0. Equals 0. So in other words, if 0 is contained in there, then we would fail to reject. But in this case, 0 is not contained in here, so we reject the null. Okay? All right. All right. Let's move on to number 5, because you can read that on your own. Do men talk less than women? So that's obviously something that's been debated for a long time. We have a data set here. We have 2 samples, one of men and one of women. N1 is 186, that's the men. N2 is the women with 210, right? So these are all the summary stats. So this is like something you might have to provide if you were being asked something and they gave you a bunch of data. You want to provide all this information. Right away, you should see that this is X bar, right? So this means mean. We're talking about mean, right? And this right here means sigma is not known, which means use student t. Student t distribution, okay? All right. So that means your test statistic will be coming from the student t distribution. As you can see, it comes from that. All right, so you get this. Hopefully you'll verify that you got the same answers as this. If you're going to be putting this in your calculator, you could do stat, go to tests. This is a 2-sample t-test. And you just put all that in there. And then we have the stats. So let's just do that. So we have stats. X1 is 180. Wait, that's X1 bar. 1,566.5. 15,668.5. S1. N1 is 186. All right. And in this case, let's look at our alternative. It tells us that it's less than. So if we go down here, we should say mu1 is less than mu2. In other words, you're saying that women talk more than men, right? It's not pooled, so don't worry about that. Hit calculate. And you should end up getting the same values we have here. And you see that. So again, this t right here is your test statistic. This p-value here is your p-value, okay? And degrees of freedom, don't worry about that for right now. That's a different way of calculating it. We're not doing it that complex. So, all right. Moving on to 6. Sorry if I'm going pretty quick. The last 2 videos are really long, so let's do short. Flight arrival delays. Data set 15 in Appendix B lists arrival delay times minutes for randomly selected flights from New York to Los Angeles. Statistics for time are given below. Use a 0.05 significance level to test the claim that Flight 1 and Flight 3 have the same mean arrival time. Mean is the key right there, right? And then this is the data they give you. They give you, they give you N, X bar, and S, right? So in other words, they give you the sample size, they give you the sample mean, and they give you the sample standard deviation for Flight 1 and Flight 3. And all you do is now recode that, and then basically show how you're going to construct that. So, and it says, assume that the two samples are independent, simple random samples selected from normally distributed population, and do not assume that the population standard deviations are equal. Okay, so we do not assume that. So that means it's going to be a student t-distribution. We're saying that they're not equal is going to be the alternative, and hopefully you'll get this, and double checking your work. All right. Number 7, we have BMI, body mass index. It's computed by dividing weight and by the square of the height of someone. And so we have the male BMI and the female BMI, and we have their respective values here, right? So assume that two samples are independent, simple random samples, like from normally distributed population. Do not assume the population's is equal to the following, right? So test the claim using the p-value method or critical value method. So you can do both. I always recommend that you do both. It's very easy on your calculator to do both, and it can double check your work very quickly. So 9.4 is 2 dependent samples, match pairs. There's 2 problems here, and I'll probably go through them kind of quickly. But the first one is looking at ages of actresses and actors at the time they won Oscars for the categories of Best Actress and Best Actor. So as you might be noticing right here on the trend, it looks like to me actresses win it at much younger ages than actors, okay? So assume that you want a 0.05 significance level to test the claim that paired sample data come from a population in which the mean difference is mu d equals 0. Find d bar. So how do we find d bar? Well, again, d bar is just taking the difference between these two and then adding them all up and then taking the average of them, okay? And that's how you get d bar. So in other words, this would be negative 22, negative 4, negative 44? No. 34. And here it'd be positive 11, and here it is negative 9. So if you added all those together and then divide by 5, you should get this negative 11.6 years. You can also do the standard deviation the same way. My suggestion is you take these values right here and you go back to stat, you put them in edit, and you do a list. So like in this case, if I did L4, negative 22, we'll find out if my math was wrong earlier, 11, negative 9. And I go to stat, and I'll do one variable stat. What list was that? L4. Negative 11.6, good, my math is good. And you see the standard deviation is 17.2, which is the same thing right here. So now that you have both those, this is just a student T test, okay? Now, this is really important, though, to keep in mind that this is matched pairs. There's a little small difference between matched pairs and just doing a 2-sample t-test, okay? They're very similar, but keep in mind, okay? Well, so hopefully you got these values here. Now, last one is Friday the 13th, unlucky. So I'd read through it all, but basically it's just doing the same thing here. And in this case, you might find does not include 0. It appears that there is sufficient evidence to warrant rejection of the claim that when the 13th day of the month falls on a Friday, the number of hospital admissions from motor vehicle crashes are not affected. Hospital admissions do not appear to be affected. So, something to keep in mind. To me, looks like 0 is not included. So, if 0 is not included, you would show that you would reject the null in favor of the alternative. So, all right, that's it. That's all of this one. That's still 20 minutes. So hopefully you're able to follow along with it. If you have any questions, feel free to email me again. Yep. So.